In Hyperlink's board sim, you can simulate all the nets on the board, a group of nets, or an individual net to look at signal integrity, crosstalk, and timing. So if we look at this net and analyze it in the oscilloscope, we can see that it has overshoot and ringback issues that are very serious. But a quick trip to the Terminator wizard will give us a suggestion for an optimal termination to address those issues. So if we apply the values and resimulate, we see a greatly improved waveform. And these large overshoots and ringbacks were caused by reflections, and the termination basically eliminated those reflections. Now, when we add a terminator in board sim, it gets implemented as a quick terminator, which has the actual termination value along with some routing. So if we wanted to see what it looked like, say, with routing on the top layer and half an inch of routing instead of 100 mils, we could put that in and resimulate. Notice it looks a little bit noisier, but basically still a nice waveform that's gonna meet our requirements. We can also export this net into line sim for further exploration. And if we look at this net in line sim, we can see that there are a number of features that we can go in and edit, like the model type, the transmission line parameters, the vias if necessary, and we can also sweep through a number of values. So I can look at different buffer models, different dimensions on the transmission lines, or different passive component values. So if I select this terminator here and I enter values between 30 and 70 ohms, I can see the effect of what those different termination values are going to have on my simulation. So if I simulate those sweeps, I can see what the different terminator values are going to produce. So if I zoom in here on one of our logic thresholds, I can see that the smaller terminator gives us an earlier switching, and the larger terminators delay the signal some. So you can look at the different sweep values and figure out which one is going to give you the best timing, and then also you can look at the voltage thresholds and see which one is going to give you the minimum overshoot. So for instance, if I use 55 ohms here, I get minimum overshoot, but that had a larger timing effect. So you can basically use the different sweep values to determine which termination value is going to give you the optimum solution for both timing and voltage.